Hello everyone. Welcome to the eCYBERLESson classroom. My name is Matt Hartman and I'll be your instructor for this lesson. Today, we'll be looking at stating a hypothesis. Now, in case you aren't familiar with the term, a hypothesis is an educated guess as to what will happen in a given situation where you don't know the outcome. It could be as simple as, if I drop a pencil, then it will fall to the ground. Now, you might argue that I know for sure what will happen, and in that case, you're right. I'm fairly certain it will. But what if I was in space? Then I'd have to change that hypothesis about dropping a pencil. But what I want you to pay attention to is the format of my hypothesis. If I do something, then something will happen. You're going to use the same format for your hypothesis. So let's start by finding a problem that exists in your community. You'll do this part on your own, but I'll give you an example. The problem I found is a local neighborhood is experiencing flooding after every rainstorm. This doesn't sound too good to me, so I need to ask some questions about this problem. I'm going to start with the basics. So, who is this affecting? Clearly, it's affecting the folks who live in this neighborhood. Okay, now what? So what is happening? Or maybe what is causing the flooding? Well, the rain is causing it, but it might be more than rain. Looks like a local stream overflowing is causing the flooding, and the stream is overflowing because too much water is running into it. When is this happening? After every rainstorm. Where? In the neighborhood of Pleasantville. Now, why? Why is this stream overflowing? Well, too much water is going into it too quickly. But why is that happening? Looks like it's because the ground can't absorb the water fast enough because so much of the area is covered in pavement. How is this flooding happening? I'd say the stream is overflowing and the water is ending up in the people's basements. Okay, now that I've answered the questions, it's time to make a prediction, a hypothesis. Remember that a hypothesis can be tested. There will be two variables, the independent variable and the dependent variable. Do you know which is which? Let's take a look. Remember that format of the hypothesis with if I do something, then something happens? Well, our two variables are right there. Remember, a variable is something that changes. So the first one is what I change, and that's called the independent variable. You can remember that because I change the independent variable. Both have I as the first letter. Then the other one that is changed is what happens because of what I changed. It's dependent on the change I made, so it's called the dependent variable. So here's my prediction. If the pavement allowed water through, then the stream wouldn't flood every time it rains. So which one is my independent variable? Yep, that's changing the pavement. And what is the dependent variable? The stream not flooding every time it rains. These are the two things that changed. One I changed, and one changed because of what I changed. So let's take a look at a checklist and make sure I have a good hypothesis here. Let's answer each of these. 1, yes, it relates to the information I had in my problem statement, which was that there's flooding in this area. 2, yes, we saw that it did. 3, it can be. It'll be tough, though, to actually conduct this experiment because it would have to be tested on a very large scale. So you'll have to choose something that can actually be tested yourself, not by your local government. Maybe you could create a model of the situation and test it there. 4, I didn't set any design criteria, so I may need to look at my hypothesis again. I have, if the pavement allowed water through, then the stream wouldn't flood every time it rains. So in order to set the criteria, I should say, if the pavement in the watershed allowed water through into the dirt below without holding onto it, then the stream wouldn't flood every time it rains. It's important the pavement doesn't hold on to the water, because if it does, then the water might expand in colder months when it froze and break up the road. Okay, so my hypothesis is set and ready for testing. Now, I was able to make this hypothesis because I did some additional research about why the flooding was occurring. When you work on yours, you may have to do some additional research too after you find your problem. That's fine, because without enough information, it's difficult to make an educated prediction about what will happen. Let's go to our Army scientist, who will talk to you about your task.
So give it a try. Find a problem, answer the who, what, when, where, why, and how, and then write a hypothesis. Pause the video while you do so, and unpause when you're done. and I will give you the checklist to make sure your hypothesis is ready for testing. Hello again. Do you have a hypothesis? If not, pause again and finish that up. If you do, then let's take a look at it. Here's our checklist again. Number 1, does the hypothesis relate to information presented in the original problem statement? Number 2, does the hypothesis include the independent and dependent variables? Number 3, can the hypothesis be tested through experimentation? And number 4, for the engineering hypothesis, have you set your design criteria? If you can answer yes to all of these questions, then your hypothesis is ready for testing. If not, go back and rework your hypothesis so that you can answer yes to all of these questions. As a scientist for the Army, I am constantly looking at problem statements and going through who, what, when, where, why, and how to determine a hypothesis that I want to test to solve the problem. For example, suppose the problem is that the soldiers have to eat cold food while in the field because they don't have access to a kitchen, fire, or electricity. The who is the soldier, the what is the cold meal, the when is in the field without access to a kitchen, electricity, or fire. The why is that there isn't a means of heating up the food. And how is this happening? The soldier must carry all supplies and tools while in the field and therefore does not have any means of heating up the meal. My hypothesis is if I create a special pouch that will produce heat and can easily be carried in the rucksack of the soldier, the meals could be heated while in the field. Now the real fun begins, the testing of the hypothesis. Let's go back to your eCYBERmission teacher.
Looks like it's time to go on to the next lesson, conduct an experiment. Remember, if you have any questions or problems, talk to your team advisor. If there are still questions, you can contact Cyber Guides on the forums at eCYBERLESSON.com or call Mission Control between 9 a.m. and 5 p.m. Monday through Friday at 1-866-GO-CYBER. See you soon.